11. So use the diagram to find the measure of the indicated angle and the circumference of the circle. Okay, so angle BCD. Well, angle BCD is right here. Well, BCD is supplementary to ACB, which is 60. So 180 minus 60 is 120 degrees. So the measure of angle BCD is 120 degrees. Now the circumference, I don't remember this formula at the top of your head, but it's a very simple formula. Get the board to work. Very simple formula. Circumference is 2 times pi times r, or pi times diameter. And that's because 2 times r is the diameter. 2 radii make a diameter. So, if this is either double 4 or, well, double 4, same thing. So that's going to mean that the circumference is 8 pi. And sometimes we can leave it like that, and the instructions will tell you, or we just take 8 times 3.14 and get 25.12 units. So we don't have inches or anything. Right? YMX. YMX is right here. So that's clearly going to be 90 degrees because we have 90 right here. Love the board. Since we have 90 right here, that means we're going to have a degree measurement of 90. Okay? And then we're just going to take circumference is 15 times pi. That's the diameter. Or again, if I did 15 times 3.14, that would give me 47.1 units. Okay, so RPQ, again, always look and see where it is, RPQ. Well, basically, take 135 and 90, add those together, and get 225. And then subtract that from 360, and we're going to get 135. So the measurement of this angle is 135 degrees. Now, this one we don't have diameter, do we? We just have this radius right here, 8. But again, we just double that. So circumference is 16 pi, and that's going to be a little bit more than the last one. And obviously, if you hit the pi button, it's going to be slightly different, and that's okay. And that's it. Okay, indicated measure. Now notice, we're looking for an arc here, WZY. So we're looking for this arc right here, WZY. So if you notice, these chords are interesting because basically these two chords, WY and XZ, are equal. All right? So what we know now is that they both contain, this arc and this arc overlap at the 40, which makes this right here also 90 degrees. Now if we wanted to, we figure out this by adding those three and subtracting from 360. Okay, DF. For some reason, F is not in here. F is right here. Yes, that is an F. So, since this is a chord, and it's intersecting a diameter at 90 degrees, that means it is bisected. So we just do 6x minus 3 equals 4x plus 7. And it gives us 2x equals 10, x equals 5. Now, is that our answer? No, because we want df, so we're going to plug 5 in here. So df is 6 times 5, which is 30, minus 3, which is 27. Okay? Put 90 degrees up there. Okay, CQ, which is this piece right here. That's the hypotenuse of that right triangle. So remember, since we have this chord and this chord are both the same distance from the center at a 90-degree angle, the chords are equal. So we do 26 minus 2x equals 5x plus 5. I'm going to add 2x and get 7x. I'm going to subtract 5 and get 21. So x is 3. Okay? So, what that gives me is, put 3 in here, 5 times 3 is 15, that means this is 20, and so is this. Which makes this 10, we have 8, so we're just going to do the Pythagorean theorem. 8 squared plus 10 squared equals c squared. And that's going to be 164 equals c squared. Square root both sides. We get square root of 164, and we get 12.81. So CQ is 12.81. All right, so even though we just went over it, here is the formula for circumference of a circle, which is the distance around the circle. 2 pi r, or pi times diameter. Okay, find each measure of each indicated measure. Circumference of a circle with a radius of 9 centimeters. Notice it does give us centimeters this time, so we're just going to do a squiggly. Circumference is, now remember, we have a radius, so that's going to be 2 pi r, which is 9. So that's 18 pi. We can leave it like that, or we can multiply it out and get 56.55. And we do have centimeters. And that would be centimeters right there also. Now we're working backwards. Okay, we're trying to find the radius. So 2 pi radius equals 26. Okay? That's the circumference. We know the circumference this time. So we're going to divide by 2 first and get pi r equals 13. Oh, let's just do that over. 13. Okay? And then we're going to divide by pi, and we're going to get a radius of approximately 4.14. And that's going to be meters. Now remember, it can be slightly different if you divide by the pi key or 3.14, but I will accept either one. Okay, arc length. New concept here. In a circle, and it's this new formula, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure to 360. So, arc length of AB, the red portion right here, this right here, well, this right here. Okay? That arc length divided by 2 pi r is equal to the measure of the arc divided by 360. Or, to simplify this, we can just use this formula right here. So we take the measure of the arc divided by 360 times 2 pi r. Okay? Moving on. Let's do some practice with it. Okay. Find the arc length of AB. So, we're going to take this, love it. This measure right here, AB. Okay? And we're just going to plug it into the formula. So 60 degrees divided by 360. So we're just going to divide that and multiply by 2 pi and the radius, which is 8. And we're literally just going to crunch those numbers. So 60 divided by 360 times 2 times pi times 8. And I'm just going to run it through. And we're going to find out that the arc length, I don't know what I'm doing there, is 8.38 centimeters. Okay? Now, for B, it says find the circumference of Z. All right? Well, notice it's got different information here. It has the angle here, 40 degrees, and we actually have the arc length. So we're going to plug the numbers in differently. So we know the arc length, 4.19. And we're going to divide by the circumference, which we don't have, is equal to 40 over 360. And this is the other variation of the formula. All right? So what we have here, we reduce this right here, we have 4.19 over C equals 1 over 9. And we just cross multiply and divide. 9 times 4.19 means the circumference is 37.71 inches. Sorry, not centimeters, inches. Okay, last but not least, RS. Okay, so we're trying to find RS right here. Well, let's look at what we have. We have a radius of 15.28 right there, and we have this measure here. So we do know the arc length, and we're going to do that divide by 2 pi radius, 15.28, is equal to the measure of RS, which we're trying to find, over 360. So there's 3 different variations on the same concept. All right? So to get this by itself, we're going to multiply both sides by 360. So we're going to put 360 over here, and then we're just going to crunch all those numbers. 360 times 44 divided by 2 times 3.14 times 15.28. And we're going to find out that the measure of RS is equal to 165 degrees. Remember, this is just plugging numbers into a formula. Okay, real life problem. Here's a car tire. Okay, to the nearest foot, how far does the tire travel when it makes 15 revolutions? Well, first we need to find out what 1 revolution is. And a revolution is basically 1 time around, the circumference. Okay? So, first off, we're going to find the diameter. We need that to find the measurement to do the circumference. So, the diameter is going to be, let's see what we have here. We have 15 from here to here. We have 5.5 here and 5.5 here. So basically, if we add these 3 numbers up, we find out that the diameter is 26 inches. Okay? So the diameter is 26. Circumference is pi times diameter. Okay? So we're going to take 26 times 3.14, and we get 81.64. So the circumference is 81.64 inches. That's 1 time around. We want to know 15 of these, so we're just going to take 15 times 81.64 and get 1,225.2 inches. Now, are we done? No, because let's look at the problem to the nearest foot. Okay? That's inches. So we need to change from inches to feet, so we need to divide by 12. Because there's 12 inches in a foot, which means we're going to get an answer of 102.1 feet. Okay, another real world example. Curves at the end of the track are shown are 180-degree arcs of circles. Okay? In other words, if we cut this here, we have a semicircle. And if we cut this here, we have a semicircle. Okay? Which is why they're 180 degrees. The radius of the arc for a runner on the red path is 36.8 meters. About how far does this runner travel to go once around the track? Around the nearest 10th. Okay, so we're going to work with our same formula here. So first off, if you just think about it, we're going to know the distance around the track. Well, what we have here is we have 84.39 and 84.39. That's the straight sections. So let's calculate that first part. The straight sections is 2 times 84.39. That's 168.78. So that's the straight part right there. Now we need to find the measurement right there. Now, one thing that might be confusing is this 44.02. Let's look at that really carefully. 36.8 is the distance to the inside track, the red track. 44.02 is to the outside. So we don't need this for this problem. That's why we're not using it. Okay? So, now we basically just need to find the arc length for that circle. Okay? Which actually, I did that wrong before. We want this arc length right here. Okay, the inside track. Sorry about that. Okay. So what we're going to do is, we need two of them. So let's do the curves. So think about it. If we put this together, basically we have a circle that looks like that, right? With a radius of 36.8. So we're basically trying to find the distance around that, which is the circumference. So that's going to be 2 times pi times 36.8. Which is 231.1. So if we add that to the 168.78, we get 247.8. Meters. I don't know what happened there, calculator, because that definitely does not make sense, does it? 231.1 plus 168.78 is 399.88. Does it say the nearest foot? Nearest tenth of a meter. So 399, that's not a 9, 0.9 meters. And that's the distance run, the inside track. And the last new concept is a very simple conversion, converting degrees to radians, radians to degrees. Okay, so to go from degrees to radians, there's two variations of it. Okay, you take 2 times pi times the radians divided by 360, or simply pi divided by 180. Okay, this is going to be the easier one. Less work, it's kind of simplified. And over here, going from radians back to degrees. Similar concept. Here's a simplified version. Right? So going from 45 degrees to radians. Right? So basically it's just going to be 45 times pi over 180. And you're literally just going to have 45 pi over 180, and we're not going to change pi to 3.14, and we're just going to simplify this fraction. That's all we're doing. So that's going to, that's going to be pi over 4, because 45 goes into 180 four times, so that's going to be pi over 4 radians. We use abbreviated RAD. Now over here, going the opposite direction, we're going to take our 3 pi over 2 times 180 over pi. The pi's cancel, and we're just crunching the numbers. 3 times 180 divided by 2. Type that in your calculator, and you get 270 degrees. That's it.